Okay, kids, so 3U assignment, chapter 4, question 22. Let's read it. It says, how much water at 82 degrees Celsius must be added to 0.20 kilograms of water at 14 degrees Celsius to give it a final temperature of 36 degrees Celsius? So this is a heat transfer question. And hopefully you learned from the video lessons and the cartoons that I got you to watch and the reading of your notes and textbook. I hope you are familiar with this equation right here, because basically this equation says whatever energy is lost by one object has to be gained by the other. So for example, if something lost, I'm just going to make an imaginary number, 100 joules of thermal energy, right? Lost it, that would be like negative 100 joules, right? The other object gained 100 joules. So that would be positive 100 joules. So when you add negative 100 joules to positive 100 joules, you get 0. So we're assuming that all the energy transferred over. All right. So you need to also remember the equation for heat transfer. So it's the mass of the object. Now, since this is the object that's losing the heat, it's the mass of the hot object. In this case, it's water, hot water, multiplied by the specific heat capacity of the hot water times the change in temperature for the hot water, plus the mass of the object that's gaining the heat. In this case, what's gaining the heat is the amount of cold water times the specific heat capacity of the cold water, right? Multiplied by the change in temperature of the cold water. And that has to equal 0. Now, what's very interesting here is both materials are water, hot water and cold water. So that means specific heat capacity for the hot water and specific heat capacity for the cold water, it's the same number. So I'm going to divide the equation by that. So it removes it completely. I've divided through. So we're left with mass of the hot water. Then look here. Temperature final. Ooh, that's ugly. Let me fix that. There we go. Temperature final minus temperature initial for the hot water, right? Plus mass of the cold water multiplied in bracket temperature final minus temperature initial for the cold water equals 0. Now, the interesting thing about this is when heat transfers between two objects, eventually they will come to a common final temperature, right? One will lose temperature and get there, the other will gain temperature and get there, but it's a common final temperature. So as far as I can tell here, you know the final temperature, right? You know the initial temperature of the hot, right? You know the amount of cold water you got. You know the initial temperature of the cold water, right? So the only unknown left here is mass of the hot water. And you've got to do your work and figure it out, right? Is this helping you? Okay. Thank you, kids. Bye-bye.